In January 1982, 10 Arabian Oryx stepped out of transport crates onto the gravel plains of the Jiddat al-Harasis in central Oman. The lead bull moved first. He drove his hooves into the flat, stony ground, dropped his head, and began tearing at the sparse, dry grass with the full force of his neck. The cows spread around him in a loose arc, pawing at the sand between rocks, using their front hooves to break the compacted surface and expose the soil layer beneath. No one told them to do any of this. The ground they were standing on was classified as hyper-arid desert. Annual rainfall was under 40 millimeters, most of it evaporating before it reached plant roots. Surface temperatures in summer exceeded 60 degrees Celsius. The gravel plain had no trees, no surface water, and less than 3% vegetation cover. International conservation bodies had already written the species off. The Arabian Oryx had been declared extinct in the wild in 1972. Every living oryx on the planet existed inside a zoo enclosure. The 10 animals now standing on the Jiddat had been bred in captivity. None of them had ever touched wild ground before that morning. And what those 10 animals did to that dead desert over the decades that followed would force the conservation world to rewrite the rules about what a species can do when you return it to the land it shaped for 1,000,000 years. What nobody had anticipated was how fast the land would remember them. The Jiddat al-Harasis is not what most people picture when they think of desert. There are no dunes, no dramatic rock formations. It is a flat gravel plain the size of Switzerland, sitting at roughly 300 meters above sea level in the interior of Oman, rimmed by distant escarpments on 3 sides and open to the empty quarter winds from the south. The surface is angular limestone gravel over hardpan, broken occasionally by shallow wadis where water ran during the Pleistocene and has not run since. In summer, the ground radiates stored heat until midnight. In winter, the temperature swings 35 degrees between noon and 4 a.m. It looks lifeless. It is not quite. Sparse perennial grasses survive in the gravel by growing deep taproots that reach moisture layers 2 to 3 meters below the surface. Herbs and geophytes persist in the shallow wadi beds. After rare rainfall, annual plants germinate, set seed, and die within weeks. A functional desert ecosystem, thin, fragile, operating on a budget of almost nothing, but functional. The oryx had lived on this system for 1,000,000 years before humans hunted them off it. By the 1960s, motorized hunting parties had eliminated every individual. The last confirmed wild oryx in the Arabian Peninsula was shot in the Jiddat in 1972. What remained was the desert without its engineer, the gravel plain still running its minimal biology, but missing the one animal that had shaped how water, nutrients, and seeds moved across it. A system with a hole in it. The question in 1982 was whether 10 captive-bred animals could fill it. Before the oryx, Oman tried the standard approach. Between 1975 and 1980, the government worked with international conservation partners to assess whether the Jiddat could be restored by passive protection alone. Stop the hunting. Fence sections of habitat. Wait for the vegetation to recover. The theory was that decades of hunting pressure had suppressed the ecosystem, and that removing that pressure would allow it to rebound. Passive protection was the idea. It did not. Vegetation surveys in 1979 showed no measurable recovery in protected areas compared to unprotected ones. The grasses and herbs that persisted in the Jiddat were doing so at the same low density they had maintained for decades. There was no trophic cascade waiting to happen, no suppressed bloom of plant life being held back by hunting. The ecosystem was not recovering because the problem was not hunting pressure on plants, it was the absence of the animal that moved nutrients and water and seeds across the landscape. Aerial seeding was assessed and rejected. The Jiddat al-Harasis rainfall pattern is too unpredictable and too brief for seeded annuals to establish without a reliable germination window. Drop seed before a rain event and the seed bakes. Drop it after and the window closes within days. Without an animal that naturally ingests and deposits seed in protected microenvironments, such as dung, hoof depressions, and body scrapes, establishment rates would be near zero. Supplemental water points were trialed in 2 locations. Animals concentrated around them, overgrazing the surrounding area within 1 season. The infrastructure created a hotspot of degradation rather than a recovery zone. Every engineered solution created a new problem. The desert needed something that moved, not something that sat still. Movement was the missing ingredient. The plan was simple and, by the standards of the 1980s, almost recklessly optimistic. 10 oryx, 9 of them born and bred in the United States, were selected from the world herd maintained at the Phoenix Zoo, with additional animals drawn from the San Diego Wild Animal Park and the private collections coordinated by the Fauna and Flora Preservation Society. They were flown to Oman in 1980, held in large outdoor acclimatization pens on the Jiddat, then released on January 31, 1982. A second release followed in 1984, and further captive-bred animals were added over the following years. The Jiddat al-Harasis tribespeople were hired as rangers, the same people who had tracked oryx for generations, now tracking them for conservation. Their knowledge of the gravel plain was the monitoring infrastructure. No GPS telemetry at that scale existed yet. Rangers followed herds on foot and by vehicle, recording movement patterns, birth rates, and range use by hand. What the rangers documented in the first 3 years changed how the research team understood what they were looking at. The oryx were not staying where they were released. They were moving long-distance directional movements that covered the full width of the Jiddat within 18 months of release. They were tracking rainfall events they could not see, navigating to vegetation flushes 30 to 50 kilometers away before the research team had even confirmed rain had fallen there. They were behaving like animals that already knew this landscape, even though not one of them had ever stood on it before that January morning. The desert was doing something to them, or they were doing something to the desert. The researchers were not sure yet which way the causation ran. 4 things happen when Arabian oryx move through hyper-arid desert. Each one is invisible at the individual level. Across a growing herd moving 20 kilometers a day, they add up to something measurable. The first is hoof aeration. Oryx hooves are wide and splayed, evolved for gravel and sand, not turf. Each step on compacted desert surface fractures the hardpan in a small radial pattern around the point of impact. A herd crossing a dry wadi bed leaves thousands of microfractures across the surface. The next rainfall, even 5 millimeters, infiltrates through those fractures rather than running off. Studies from the Jiddat monitoring plots showed soil moisture at a depth of 30 centimeters was measurably higher in regularly grazed areas than in adjacent ungrazed control plots after equivalent rainfall events. The second is grazing stimulation. Oryx graze perennial grasses down to 3 to 5 centimeters. Counterintuitively, this triggers lateral root growth and tillering. The grass responds to grazing by spreading horizontally and thickening its root network. Ungrazed perennial grass in the Jiddat grew tall, set seed, and died back, leaving bare ground between plants. Grazed grass spread laterally and maintained ground cover across a wider area per plant. The third is dung distribution. An oryx deposits roughly 1.2 kilograms of dung per day across its range. Each deposit contains viable seeds, nitrogen, and active gut microbes. Moving 20 kilometers daily, a single animal seeds roughly 20 kilometers of landscape with nutrients and plant material ingested elsewhere. Across a herd of even 20 animals, that is 400 kilometers of daily nutrient redistribution. The fourth is body scraping. Oryx rub against any raised surface, rocks, dead vegetation, and each other. The contact deposits skin-borne bacteria and organic debris into the soil at scrape points, seeding microbial communities in an environment where they are otherwise sparse and slow to arrive. 4 mechanisms, every day, 10 animals, no management required. By April 1990, the Jiddat herd had grown to over 100 animals, breeding successfully, ranging independently across more than 11,000 square kilometers without supplemental feed or water. The monitoring data from that period showed something the research team had not anticipated at that scale. Vegetation density inside the Oryx range was increasing in areas of highest herd activity. Perennial grass cover in regularly grazed zones was measurably higher than in adjacent ungrazed areas outside the range. The ungrazed land showed no equivalent change over the same period. The rainfall was the same. The soil type was the same. The only variable was whether the oryx had moved through. By October 1995, the wild population had reached approximately 280 individuals. From late 1996, poaching intensified sharply. These were organized capture operations, not subsistence hunting. Animals were taken alive for private collections. By September 1998, the population in the Jiddat had fallen from over 400 to around 138. By 2007, illegal capture had reduced the wild herd to between 65 and 100 individuals. I find that sequence almost impossible to sit with. The oryx had done everything right. The desert had responded. The population had grown for 15 years. And then humans with vehicles dismantled it in less than a decade, the same way the original extinction had happened, by the same method, in the same landscape. The difference this time was that the knowledge existed to bring them back again, and the political will to do it. By 2011, the International Union for Conservation of Nature reclassified the Arabian oryx from extinct in the wild to vulnerable. The first large mammal in recorded history to move in that direction. I keep coming back to that designation: vulnerable, not recovered, not safe. Vulnerable. After everything that went into this, that word is a reminder of how thin the margin still is. The Arabian oryx recovery didn't stay in Oman. Saudi Arabia reintroduced herds to the Mahazat as-Said protected area in 1990. The United Arab Emirates began its own program at the Arabian Oryx Sanctuary in 1994. Israel reintroduced oryx to the Negev in 1997. Jordan followed in 1983. By 2015, wild and semi-wild populations across the Arabian Peninsula had reached several thousand individuals, distributed across a landscape where the species had been functionally absent for decades. The ecological data from multiple sites confirmed what the Jiddat had shown first. The oryx's effect on desert soil and vegetation was not a Jiddat-specific anomaly. It was repeatable. The same mechanisms, hoof aeration, grazing stimulation, seed distribution, and body scraping, produced measurable changes in vegetation cover and soil function wherever herds were established on degraded hyper-arid land. The economic case is stark. The World Bank estimated in 2018 that mechanical desert restoration, scarification, supplemental irrigation, and aerial seeding costs between $3,000 and $12,000 per hectare in hyper-arid environments, with success rates under 30% after 5 years. The Oryx program in the Jiddat cost approximately $800,000 in total over its first decade, covering transport, ranger salaries, fencing, and monitoring across a recovery area of roughly 2,700 square kilometers. Do that math. What nobody talks about when they discuss the Arabian Oryx recovery is the question it raises about every other extinct in the wild species currently sitting in zoo enclosures. The oryx worked because the land it evolved on was still there, waiting. Degraded, yes. Empty of its engineer, yes, but structurally intact. How many other deserts are waiting for the same thing? In 2023, the International Union for Conservation of Nature published its most recent population assessment for the Arabian oryx. Wild and protected area populations across the Arabian Peninsula number approximately 1,220 individuals. The number in 1972 was 0. That is the full distance this story covers. It goes from a species with no wild individuals left on the planet to a population of over 1,000, rebuilding soil function across thousands of square kilometers of desert. All of this happened in the same time it takes a human to go from birth to middle age. The Oryx didn't need a new landscape. They needed the old one back. And when they got it, even in its degraded state, they knew exactly what to do with it. Sand turned over by hooves. Dry grass pulled down to the root and stimulated into spreading. Dung dropped across 800 kilometers of daily movement, carrying seeds and bacteria and nutrients from wherever the herd had been to wherever they were going. Dead desert. 10 animals, sand and grass. 40 years later, 1,220 wild oryx and soil that remembers them even when they're gone. If this one surprised you, subscribe. We publish one new documentary every week, and every story we cover is one nobody else in this niche has found yet. But Oman is not the only place where a desert came back. In our next video, we go to South Korea, where a dead war zone, sealed off from humans for 70 years, was quietly taken over by animals no one had planned for. And what happened inside that buffer zone was something no conservation program could have designed.